Hi everyone, this is Michael from Codecademy, and I am excited to be discussing virtual DOMs with you today. As a refresher, the DOM, which stands for Document Object Model, is a representation of a web page created by and stored in the user's browser. The browser takes a site's HTML, transforms it into a DOM, and then paints the DOM to the user's screen, making the site visible to the user. The DOM is stored as a tree-like structure, where each HTML element corresponds to a node in the tree. Let's look at how the browser would take an HTML file and translate it into a DOM tree. In this example, we've got a body tag containing a header that says things to learn, and an unordered list of programming languages our user wants to learn. We've also included a button with each list item that allows our user to check off the item and remove it from the list. The DOM tree will render as follows. The top node will represent the body tag. The body node will have two child nodes underneath it, the H1 node and the UL node. Now, text is also represented as a node, so the H1 node will have a child text node, and the UL node will have three LI node children, which each have a text node child and a button node child, which each have a text node child of their own. Now, you don't need to fret about all the details of how DOMs are created. All you need to know is that the DOM is a tree of nodes representing a web page that is then painted by the browser for users to see. In this example, let's say a user clicks the remove button next to the Ruby list item. We want to remove this list item in response. That node and all the nodes underneath it will be removed from the DOM. Whenever a browser detects a change to the DOM, it repaints the entire page using the new version of the DOM. But wait, did we really need to repaint the whole page? Didn't only one part of the site change? For example, why did we have to repaint the header if nothing about it is different? Comparing two DOMs to determine what parts have changed is time-consuming. As a result, it is actually faster for browsers to simply repaint the entire page whenever a user interacts with the site, instead of determining what, if anything, has changed. However, what if there was a fast way to make these comparisons? That's where the virtual DOM comes in. Some front-end frameworks, like Vue and React, create their own representation of the DOM as a JavaScript object. Whenever a change is going to be made to the DOM, the framework instead makes a copy of this JavaScript object, makes the change to that copy, and compares the two JavaScript objects to see what has changed. It then informs the browser of these changes, and only those parts of the DOM are repainted. Making changes to JavaScript objects and comparing them is far faster than trying to do the same with DOMs. As a result, using JavaScript objects, we can quickly determine what to repaint in a way that we couldn't by just relying on the browser. Since this copy of the DOM is stored in memory as a JavaScript object, it's called a virtual DOM. Using a virtual DOM allows frameworks to identify when a user interaction doesn't require a repaint at all, limits repaints to only parts of the site that have changed, and groups together repaints, so that one user interaction doesn't require the entire page to be repainted multiple times. In summary, repainting a page takes time, and modern web apps constantly have tons of small changes. Attempting to repaint the whole page for each one makes sites slow and buggy. Using a virtual DOM allows us to only repaint what is necessary, greatly improving page performance and creating even more amazing user experiences.